Yeah, very good morning to all of you. I'm fairly impressed that so many people actually came at 9 o'clock on a Sunday morning. My name is Carsten Rönsdorf. I'm with Ordnance Survey, the National Mapping Agency of Great Britain, and we're one of the project partners in the ISCO project that Raffaele just introduced. Before I go into slightly more technical detail, I just want to highlight that I was actually quite pleased to see Raffaele showing the video. And while you might argue that it's quite low in terms of technical content, in particular if you came for that today, then there probably wasn't too much in it. It's important and it's good to communicate to I think outsiders out of the geographic information or Inspire community about what we're doing. And I think a video like this can absolutely help to do this. So when I came here on the plane yesterday, I sat next to a left-wing political scientist, and I tried to explain Inspire, which was interesting. So I tried to find reasonably simple words to try to outline what we were doing here. And I think it came to the point after kind of the third little bottle of wine or something like that, that we got into kind of the conflict between, I think, our quite technical and technocratic view of the world and then the political view. And I think we should really recognize that whilst within a community such as Inspire and at this conference, we talk to ourselves quite a bit, but there is the need for further outreach, and I think we need to talk about it externally as well, and we probably need to do this more and more and more, because I think there's actually something very good in what we as a community have to offer in terms of at least trying to solve some of these problems. So, how do you communicate something technical? So, the theme of the presentation is it time for 3D? And the nice thing about 3D is that you can show lots of nice pictures. So, this is, I think, a very nice looking model of some buildings, beautifully rendered. That's an image from Hasso-Plattner Institute in Germany, who are quite good on doing these type of things. And yeah, it's nice to show nice looking models in order to communicate something. And there is an aspect of that kind of relates to the video that Raffaele just showed. But there's a little bit of a problem with this. And when it comes to geographic information there, and 3D modeling in particular, we quite often talk about this iceberg model that you see there on the screen. So the analogy is that the visualization part is only the 7th or so of the iceberg that sticks out of the water, and there is an awful lot of stuff down there which is perhaps even more important and you shouldn't really forget. And that's all the good information content and richness, or what we call the semantic modeling underneath. And I hope that I can explain to you a little bit of what that actually means. So there's been one particular topic that a number of groups have gone into, from my perspective, particularly through the Open Geospatial Consortium's working group, which is called 3D Information Modeling now, but it started its life off as something called CATGIS BIM integration. So BIM stands for Building Information Modeling, which is a particular technique that comes more out of the architects, engineers, and construction industries to model the real world, model buildings, infrastructure items, and sites. And what you see there is this continuum of scales from the world going into continents, regions, cities, sites, buildings, individual stories, or components like the lamp, or the air conditioning units, for instance, that you see on the wall. And traditionally, the worlds have been quite disparate in the sense that coming from the top, this was something that played roughly in the space of GIS, while coming from the bottom, this played roughly in the space of architects, engineers, and construction. And that is something that we're actually trying to bridge with this thing called City GML, which sits somewhere in the middle. So this is a slide that quickly explains the evolution of geographic information, which I've done here, particularly in a British context if you look into all the detail. But I think the story is not too unfamiliar for many of you in your own countries. So geographic information, well, traditionally started with mapping. So we created initial surveys in pretty much every country. Quite typically, they were kind of done on local projection systems that got integrated into a national system. Data was digitized at some point, so we're somewhere, oops, if my cursor comes back in the middle here. Then, at least in Great Britain, we object build our data, and really the next natural step will be to have 3D information available, which have been working on for quite some time. So in terms of moving forward, I figured it would make sense to list a number of key assumptions that are, well, predictions in a way, but I don't think there's anything really, or there shouldn't be anything really surprising in there in terms of if you look into the future or what we might see. And I think there's this very, very big and potentially very disruptive theme in there that says with computing and web access and mobile devices and smartphones and all of that, or everything being web enabled, if that goes mobile, then really location information becomes so much more important. And I think that's actually quite good news for our industry, for our community, because we kind of live off location information or geographic information. I think there's also, well, maybe that's more of a hope, that geographic information really is the key to integrate all kinds of business information. And with business information, I also mean kind of, environmental information, so not necessarily information in the commercial world. So that roughly relates to this 80% of all information can be attributed to location. The next one says, well, future geographic information will be 3D. And I absolutely think it will be, but there's a slight caveat on this that says, well, and it's actually 2D as well, and as this is quite often more appropriate. So there isn't necessarily a divide from we're doing something that is less good in 2D now and we need to move to a world that is better because it's 3D. That's absolutely not the case. But if you have geographic data that can come out as well in 2D and in 3D whenever it's appropriate, I think that's probably the best way forward. Then there's this rather big theme that I think we've experienced over the last few years, in particular with the web services notion of Inspire, that really the notion of data sets as we know it in terms of a GIS file or a map, if we go further back, is really on its way out, and it's replaced by dynamic or more dynamic queries such as a WFS web service query, for instance, and well, God knows what we will experience with much more sensors coming online in the future. An important topic, I believe, will be the integration of indoor and outdoor spaces and concepts and perhaps navigation between those, and that, well, will have to be seamless if it should work. And then integration of data, well, should really be simple and much simpler than it is today. So there's quite a lot of stuff for us to work on. So why 3D? You can do an awful lot of stuff regarding geographic information in 2D, absolutely, but on a high level, you can do an awful lot of things with 3D, I believe, in a much better way. So you can communicate geography, I think, in a much more natural way. It's not just from the author perspective of looking down into a map, but you can actually place yourself or the camera or the view on the street, for instance. You can experience place. You can kind of take off into virtual reality and immersion. Hopefully it will be better to understand spatial relationships. There's a big theme around simulating the real world and different options and testing them. And then there's this idea that you can use it to manage your city, to draw information from all kinds of different disciplines into a fairly holistic 3D model and have this sit alongside the physical reality of the world. There's one area where 3D really goes way beyond 2D, because in 2D, in more traditional geographic information systems, we have our layers of data that we put on top of each other. And quite typically, everything that's contained, at least within the layers, is kind of done to the same specification or the same level of detail, the same scale. And one of really the key concepts behind 3D geographic information is that there is now a platform in which you can integrate a lot of different data, different in terms of the data's resolution or the detail that's actually shown. And that actually doesn't stop with 2D data. So for this regional model or level of detail 0, as we call it, that can as well be integrated into a 3D environment. So there is this stepped approach from talking about regional models into city models, which may be block models of buildings, for instance, into more intricate site models, some architecture details, and then bridging into the interior of buildings and spaces, and that can actually work underground as well. So, how to start with 3D? If you've never really looked into it, then the question is, well, how do I get started? And I think what's quite a popular approach is to start with a particular vendor. The reason the slide is empty here is that I hope I won't say any bad things about vendors as such, but perhaps a slight problem with software vendors is that whatever question you ask, the answers you get, or the answer you get is probably pretty much the same, because they have a limited portfolio of things that they can sell you. And whilst software vendors are important in terms of implementation, doing something practically, it might not be the best point to start. So I would rather suggest to start with some Lego. And I've actually bought countless boxes of Lego on my company credit card for the team to play around with. So that's always a good starting point. It's also a good idea to look at what others have done. And these are just a couple of examples, again, fairly simple screenshots from data and projects that the Special Interest Group 3D, the SIG 3D in Germany, has pulled together and published. So there's an awful lot of stuff available. Another example from Germany is this 3D city model of Berlin, which is quite a big and sophisticated one. They tell you about it on their own website, so that's also a good starting point. In January this year, we did a joint webinar with the OGC and Directions magazine in North America. And we pulled information together, mainly based on the Dutch 3D pilot. And in the Netherlands, they have done really fantastic work on bringing a community around 3D geospatial together. And this is a good starting point if you're interested in this to listen to and have a look. So finally, coming to this thing called CityGML, which is an OGC standard, Open Geospatial Consortium standard, since 2008. And it is essentially two things. It's a data exchange format, so it's, in very simple terms, something like a shapefile, but much more expressive. And it's an information modeling approach. Now, what does that mean? Well, it means it simply, or it tells you how to do 3D modeling. So it has a number of assumptions and concepts in there that even if you don't store the data in the CityGML format as such, are actually very, very useful. And this level of detail model I showed a few minutes ago, where you go from the regions into the interior of buildings, is basically lifted from this specification, and that's a model that everybody is using today. The specification is cut down into a number of different themes. And what you see there as verticals are the kind of topic areas, the thematic areas that we address. So these are buildings, street furniture, transportation, water, vegetation, land use, and actually in the newest version a couple of others. What we then also do is to add, or is to have an extension mechanism that you can utilize and use that kind of as a template and then add your own stuff. So one of the problems with, well, data models and standards, particularly OGC data standards and GML in particular, is that it's more a language rather than something that can be used out of the box. And the intention behind CityGML is to produce something that you can actually use out of the box and that should cater for 80 or 90% of your requirements. And for the remaining 10 or 20%, which are typically quite individual, there's an extension mechanism that allows you to add new properties, new attributes, new features, or even completely new themes. So people have created a theme around noise, a theme around utility, a theme about tunnels and underground. A couple of examples on this. There's a fairly good implementation of CityGML out there, which is the 3D City database, which I'm very happily promote here because it's actually an open source project done by a university. So that is very freely available. And with this example, what they've done in Berlin is to create a solar atlas. So what you see, the colors on the roof, on the roofs you see there, indicate the solar potential of individual buildings that were created by or calculated by a simulation package. This slide basically shows that you can use one single city model, one single 3D model and representation to do a lot of different things. You can integrate data from regarding heat emission of buildings, then the solar radiation. You can do something around utility networks, solar potential, and so on. And that can all be done based on one, technical platform based on one data set. So to make a quick reference to the ISCO project that Raphael has mentioned, we have three different use cases, one around mobility, one around energy and solar, and one around noise. And what this project aims to create is 3 different extensions to the CityGML standard that can then be used by the community, by you, in a very similar way. So we're extending the standard, if you like, to go into these particular topic areas. CityGML by now is used quite extensively across Europe. So within Germany, you will find pretty much every state or city using it. It's becoming now part of the national data model in terms of the official surveying. We have a few problems in the United States and North America where it still hasn't completely caught on, which, it's a bit of an issue with software vendors, as a lot of the big ones tend to be North America based. And finally, we have Inspire. So I thought I mentioned this here because there's a particular data specification in Annex 3, which is the building theme, which is almost a straight copy of CityGML and the CityGML model. And there's something that we've only discussed last week with Michael Lutz from JRC and the Open Geospatial Consortium, and that is to have another extension of CityGML, which actually makes it an official encoding for Inspire. So we hope that we have that ready and published and kind of completely done within the next year. I just skipped this. This is another screenshot of Berlin, list of software supporting it, because at some point you actually need software. So in order to start with 3D, I think it's a very good idea to start with existing data, and particularly around buildings. 2D building footprint data, I think is available in most cities, in most countries. You need to integrate some kind of height values in order to lift this up to the 3rd dimension. But that can be really as simple as sending a student out with a disto to measure up the height. So I've talked to quite a few people who have done that, who figured that this is quite a good and easy way into 3D. If you want to go a bit more advanced and cover a larger area, then you will have to use some kind of digital surface model for that in order to get access to a lot of heights. But that doesn't necessarily have to be LiDAR data, which is still quite expensive to get hold of and quite expensive to process. So what Ordnance Survey, what we are doing in-house, is to use our stereo imagery that we capture anyhow to extract the heights from there. And I believe IGN in France have done a very similar way. And then I think what's also key is that you can build your model over time. You don't have to create the whole city, the whole state, the whole country in one go. It can really be built up over time by different and disparate information coming together. So since Raffaele has talked already a lot about smart cities, which is a notion that I think is important, but sometimes a bit, not necessarily misunderstood, but it means different things to different people. I think going forward, it's probably quite an important theme, and 3D can certainly help to make that happen reality, and I think Inspire can as well. So, over the last 5, 10, 15 years, I think we've seen that 3D models have really grown in terms of the space they've occupied, the geographies they've occupied. So they've grown from sites to parts of the cities, to suburbs, to cities, to regions. We've seen examples that they've grown to countries such as Netherlands and Germany, and I think with Inspire there is at least a chance, and while Inspire is not completely 3D, there are certain themes that are or might be that it can grow to countries. So, from sites to cities, to regions, to countries, to continents. It's time to get started with 3D if you haven't done so already. Thank you very much.